So when we're doing transformations with circles, remember we talked about earlier, we could do this with lines, we've done it with absolute value, we've done it with parabolas, we've done it with square roots, and now we're going to work with circles. And remember, circles are a very special ellipse. Now, when you're working with circles, what you'll notice is that you have not just an x, not just a y, but you have x squared and y squared. So the equation of a circle with the center at 0, 0, which is called the origin, and a radius of 1, looks like x squared plus y squared equals 1. And if you were to graph that, and you notice that you have 1s here, your circle would look like this. So a very basic circle. In general, what they call the standard, the general form of a circle is x minus h parentheses squared plus parentheses y minus k parentheses squared equals r squared. And like with any of our other functions, this h and k thing is really telling you how something moved. And so you may recall that when things move around and they're on the inside, thank you, of a parentheses, they do the opposite of what you would think. So like for example, inside the parentheses, the first one, if you saw x minus 3, that means it moved to the right 3. If you see y plus 2, that means it went down 2. So just like with our other stuff, it's on the inside, it's the opposite of what you would think. And we'll do some examples so that you know. So example number 1. Let's look at an equation of a circle with a center of 2, 3, and a radius of 4. If I look at the light blue equation and I want to write down what that would look like in the standard format, I would write it like this. Parentheses x minus 2 squared plus parentheses y minus 3 squared equals 4 squared. If on the right-hand side you wanted to write down 16, you could. And so what I want you to see is as you look at these, the h was the 2, which was the x value. The k was the 3, which was the y value. And the radius was 4, which was given to us. And we put it there that was being squared. So every number that they give us, the center and the radius, goes in a certain spot and the x and the y stay. All right, let's try another one. Let's go with, in this second problem, they throw some different things in like a decimal and some negatives. Still, x, and it's minus a negative 2, so it's plus 2. This is where I'm talking about where it looks like the opposite of what you would think. And then y minus 4 from the center, and that's being squared. Don't forget the squares on the parentheses, equals 6.5 squared. In number 3, they kind of go the other way this time. They talk about the equation and say, hey, wait a minute, where's my center? What's my radius? And what quadrant am I in? So just in case you don't recall, if you're looking at a graph, this is quadrant 1, 2, 3, and 4. And as I look at this equation, what I notice is that I have a center, and the center are the opposites of the things that you see. So the center is going to be at 3, negative 8. And if I'm looking for my radius, the radius will be equal to the square root of that 81, or in other words, 9. And if I want to tell you what quadrant it is in, all I would have to do is talk about where the center is. So at 3, negative 8, that means I'm somewhere over here. That means that when I get done graphing this, I should be in quadrant number 4. In ellipses, they're written a little bit different. So in this particular ellipse that they're talking about in the example here, They tell us that the center is at 0, 0. Now this center is not actually part of the ellipse, but I'm going to put a dot there because the cool thing about ellipses is everything is based on the center. So everything is in reference to the center. It tells me that based on this center, I want to know that the horizontal distance is 3. So I graph that, the horizontal distance being 3. So here's the horizontal distance from the center. Here's 1 point. Here's 1 point. Then the second thing that they tell me, besides the horizontal distance, is they tell me that the vertical distance does it say something? Where is it? Vertical distance, there it is 6. So I know that from my center, the vertical distance is 6, so I write it like this, 1 dot up there, 1 dot down here. And I could graph this ellipse. The actual graph looks like this. I just connect all the dots with what maybe when we were little kids called an oval, but now we know it's called an ellipse. And that's what it looks like. And the crazy thing, so this is the graph off to the right. The crazy thing is, here is what the equation would look like. So I have x minus 0 all over 3 squared plus y minus 0 all over 6 squared equals 1. Now if I wanted to, of course, I could rewrite that as x squared over 9 plus y squared over 36 equals 1. And what I want to tell you is, like the circles, they always have an h and a k, but unlike the circles, it's always equal to 1. And if you look underneath the x thing, and you see a number, and it's not in a parentheses, the square root of this number is how far you go left and right from the center, or in other words, horizontally. And if you look under the y thing, and it's not inside a parentheses, and you look at that number, if you take the square root of that number, that's how far you go up and down from the center, or in other words, vertically. If it's in the parentheses, you can see the numbers, how far you go. So if you look at underneath the x thing, there was a 3. That means from the center I go left and right 3, because that's the x direction. And under the y there was a 6 in the parentheses. That means I go up and down 6 from the center. Okay, so number 2, the second example says, let's write an equation now. They give us some information, let's write an equation. So if I'm writing this equation, what I know is I need to have a